Assalamualaikum and hi. Today I am with three others member. We present about gravimetric determination of chloride. By measuring a sample mass, a quantitative analytical method called gravimetric analysis can determine the quantity of a certain substance can be found in it. The quantity and the substance mass are directly related. Using this procedure, the analyte is converted into a solid compound of a known composition and the mass of the end product is determined. The measurement of a compound chloride contained in an illustration of a gravimetric analysis. A cation that combines with chloride to generate an insoluble compound must be located in order to do a gravimetric analysis.
Next, I will introduce to all of you about the types of gravimetric analysis. Gravimetric analysis have four types, which are precipitation gravimetry, volatilization gravimetry, electrogravimetry, and thermogravimetric. Firstly is precipitation gravimetry. The analyte is separated from a solution of the sample as a precipitate and is converted to a compound of known composition that can be weighed, or known as the analyte is converted to a sparing soluble precipitate that is then filtered, washed free of impurities, and convert to a product of known composition by suitable heat treatment and weight. Precipitation gravimetry uses a precipitation reaction to split one or more parts of a solution by incorporating right into a solid or strong solution. Second is volatilization gravimetry. Volatilization gravimetry includes isolating components of our mixture by means of heating or chemically decomposing the sample. The analyte is separated from other constituents of a sample by converting it to a gas of known chemical composition that can be weighed. For example, is determination of the sodium hydrogen carbonate content of antacid tablet. Sulfides and sulfides can also be determined by volatilization. Hydrogen sulfide or sulfur dioxide evolved from the sample after treatment with acid is collected in a suitable absorbent. Finally, the classical method for the determination of carbon and hydrogen in organic compound is a gravimetric volatilization procedure in which the combustion product of water and carbon dioxide are collected selectively on weighed absorbents. The increase in mass serves as the analytical variable. Third is electrogravimetry. Electrogravimetry is a method used to split and quantify ions of a substance, commonly a metal. The analyte is separated by deposition on an electrode by an electrical current. Last but not least is thermogravimetric. Thermogravimetric is a technique of thermal analysis in which changes in physical and chemical properties of a substance are measured as a function of increasing temperature or as a characteristic of time.
So now we proceed to the methodology. First is preliminary treatment. If you want to know, preliminary treatment is the preparation of a solution that contains sample. Next is precipitation. Precipitation is analytical technique that use a precipitation reaction to separate ion from a solution. The chemical that is added to cause the precipitation is called the precipitant or precipitating agent. Okay. So next is filtering and washing off. The precipitation must be separate from the supernatant solution and other constituent of the sample. Filtration using filter paper is used to collect all the precipitate form, while washing is required too because precipitating reagent is usually added in excess. Next is drying and ignition. The gravimetric precipitation is heat until its weight become constant. Then is weight. The weighing from the precipitate is weighing by using sensitive analytical balance. And for the last one is calculation. Calculation is the calculate the mass of analyte present in the original solution.
Hi, Assalamualaikum. I'm Norfana Shamimi binti Muhammad Shukri with the ID number 2022-761-749. So, I will be here today explaining more details about the steps or the procedure for determine the chloride using the gravimetric analysis. So the first step we will go is the preliminary treatment, which what we will do here is we clean the 3 sintered glass crucible using the following procedure. So first we do is pour 5 ml of concentrated nitric acid into each crucible and let the crucible soak for a few minutes. Alright, so next what we will do is by using the water aspirator, which is shown in the slide, we draw the nitric acid through the crucible and then draw 3 portions of that water through each crucible. And then we discontinue the aspiration and add 5 ml of the 6F ammonium hydroxide to each crucible and then let the crucible soak for a few minutes. Then we will have to draw the ammonium hydroxide through each crucible by using the water aspiration and then rinse the crucible 6 to 8 times with the deionized water. And then mark each crucible with your initials and add a number and dry each crucible to constant mass by heating it at 110 degrees Celsius for at least 1 hour. Alright, so for the second step, after we finish preparing the apparatus, next record the unknown number and transfer the unknown to a weighing bottle, and then dry the unknown in the oven for at least 2 hours at 105 to 110 degrees Celsius. We can use the laboratory oven as shown in the slide. And after drying, store the unknown in the weighing bottle in the desiccator and allow it to cool. Okay, moved on. We wash 3 beakers of 600 ml beakers using soap and water and rinse them with 3 portions of deionized water, which is about 225 ml portions, and then clearly label these beakers so that you can tell them apart. Then, by using the analytical balance shown in the slide, weight 3 individual samples of your unknown and put each individual sample into its own clean 600 ml beaker. And then you must weight the sample to 4 decimal places, and each sample should be between 0.15 and 0.2 grams. And then sample that is slightly above 0.2 grams or below 0.15 gram will work, but samples significantly outside the indicated range should be avoided. Alright, moved on to the second step or the second part of the gravimetric analysis, which is the precipitation. So in precipitation, what we will do is we dissolve each sample in about 100 ml of deionized water containing 2 to 3 ml of F nitric acid. And then in order to obtain a large amount or large size of the precipitate, we must slowly, with stirring at 0.2 F silver nitrate to each solution until the HCl is observed to coagulate. Then add 3 to 5 ml additional silver nitrate. And then continue with heat the solution to almost boiling point and digest the solid for about 10 minutes. And then alternately, you can digest the precipitate at room temperature overnight or in your locker. Alright, moved on to the third part of the gravimetric analysis, which is the digestion of the precipitate. So what we will do here is we check for the completeness of the precipitation by adding a few drops of silver nitrate to the supernatant liquid, and then if further precipitation occur, add 3 more ml of the silver nitrate, and then digest the solution for an additional 10 minutes and test for the completeness of the precipitation. And then repeat this step as often as necessary until no further precipitation occur. And then in case if you have any excess or the unused silver nitrate, please make sure to pour the unused silver nitrate into the waste container. And do not return the unused silver nitrate to the reaction bottle, as this may cause the contamination. And cover each beaker with a watch glass and store for at least 2 hours or preferably until the next day. Alright, so for the fourth part of the gravimetric analysis, we will do the filtration and washing. So here, decant the supernatant liquid through a weighing filtering crucible and wash the precipitate while it is still in the beaker with a cold solution, which is wash liquid containing 2 to 5 ml of the F nitric acid per liter of the ionized water, and decant this washing through the filtering crucible. And then using a stream of wash liquid and a rubber placement, transfer all the precipitate to the filtering crucible, and once all of the precipitate is transferred, wash it with 20 ml of the wash liquid. And lastly is by using additional wash liquid, wash the precipitate and collect a few millimeters of the used wash liquid in a test tube, and then add 2 drops of the hydrochloric acid to the test tube. If a precipitate form, which means it indicates the presence of the free silver ion, continue washing until no precipitate is formed using this test. Alright, so the fifth part of the gravimetric analysis, which is we will do is dry and ignition. So basically, we will dry the precipitate at 105 to 110 degrees for at least 2 hours, and then cool the crucible in the desiccator. In the desiccator, which shown in the slide. Alright, so next we move on to the sixth part of the gravimetric analysis, which is the weighing. So in weighing, we will have to determine the mass of the crucible and the content with the analytical balance. So the cycle of heating was repeated until the consecutive weighing agreed within 0.2 milligram. Alright, so for the last part of the gravimetric analysis is the calculation. So which we use this formula to find the percentage or the purity of the chloride in the sample. So basically, we calculate the percentage of the chloride in the sample, and after the experiment has been completed, remove the precipitate from the filtering crucible and transfer them to the silver chloride waste container located in the waste hood, and then clean the crucible as described as the beginning of the procedure.
This is an example of result of gravimetric determination of chloride. In the chloride analysis, the amount of chloride in the anion sample was determined by multiplying the precipitate mass of the anion with the ratio of chloride atomic mass to silver chloride atomic mass, resulting in 0.0846 gram of chloride. Furthermore, the percentage of chloride in the sample was calculated by dividing the mass of chloride and the mass of the anion and multiplying the result by 100%, yielding a percentage of 43.42%. This calculation provides valuable insight into the composition of the analyzed sample, demonstrating the presence of chloride and its relative abundance within the anion substance. For the conclusion, in the experiment of using gravimetric analysis to determine the chloride content of an anion salt, the percentage of chloride in the sample was determined to be 43.42%. Notwithstanding the experiment's general success, many drawbacks were identified, such as the possibility of contamination during the filtration process and the requirement for meticulous management of the experimenter set up to avoid precipitate loss. This element could have played a role in the small amount of variation in the outcomes that was noted. The experiment demonstrates the usefulness of gravimetric measurement of chloride in examining material with 12% chloride concentrations, providing valuable insight for future analytical improvement.